Hey guys, David here, founder of SuperThread. So in this video, I'm going to be explaining how AI works. And the reason why I wanted to make this video is because at SuperThread, we are using AI all day, every day, and the product has really morphed into an AI product. So what is SuperThread? Just for those of you who don't know, SuperThread is an issue tracker with built-in documentation. It's amazing, it's incredibly fast, it's very polished. It's a modern kind of a tool. You should definitely go ahead and try it. But just like all the other issue trackers, the system for working inside of this tool hasn't really changed for a long time. And now, with the advent of AI, things are changing real fast. So this kind of classical type of software that we are used to is going to be changing, and we believe at SuperThread that we are at the forefront of actually innovating and changing how these things work. So just a bit of a background on myself. I've been a computer scientist all my life, and I guess the first chat program which I made was roughly in 1996 while I was a kid at college, and I made it in this programming language called QBasic. And QBasic is a language that came shipped with Windows. All Windows machines had QBasic inside of it. So I stayed up many nights typing in all the phrases, hoping that when people speak to it, it'll have the phrase that they were trying to type in. And after many nights of typing in thousands of phrases, I took it to my teacher to show it to him. And so I think I'm not really unusual in that sense. I think all computer scientists have always kind of tried and wanted to basically create this kind of general artificial intelligence. It's always been a dream of every one of us. And so moving forward, I went to university, and when I was at university, I was doing a computer science type degree, and one of the modules was AI. And I struck a chord with my teacher, my AI teacher, who's still a very good friend of mine. In fact, he got me my first job out of university. And so during this course, we were split into groups, and our task was to create a chat program. And at that time, in this country, in the UK, BBC, which is our national television, was running a program called Tomorrow's World. And each year they would do something called the Mega Lab, where the whole country participates inside of an experiment. And that year, the Mega Lab was a chat program where anyone could talk to it, and people would be kind of asked to tell whether it was a human or a real human or a computer. And so, so my best friends group actually nearly got chosen for that program. They got second place, and they made a really competent chat program, but it could only talk about Martin Scorsese movies. I believe ours was a Transformer type program, as in like the characters, the cartoon characters. But our group got second in the year. All right, so we didn't quite get. It wasn't anywhere as near as good as my best friend's program. But anyway, so this exposure to building chat programs has been there for a long time for me. But back then, I mean, AI was kind of in and out of fashion. So, there was like expert systems, and then there was like all sorts of things, and they would become popular for a while, and then it would kind of wane out, fizzle out, and then until, of course, the advent of ChatGPT, and of course, now it's here to stay. A little bit about the history of AI. So, I would say that roughly speaking, there are two camps inside of the AI field. There's the symbolic camp, led by the late Marvin Minsky, probably one of the smartest human beings who's ever lived. And there's the Geoffrey Hinton camp, the artificial neural networks camp. And that's the camp we are all living in. We're living in Geoffrey Hinton's world. And who is Geoffrey Hinton? He's a British computer scientist who kind of made big the artificial neural networks, i.e. trying to somewhat copy the way our brain neurons work, but artificially inside of computers. And So Jeffrey is a great believer in that approach, and this is where we are right now. That's the approach we are using. But when it comes to Marvin Minsky, his belief was that it was something to do with the language, and kind of a symbolic, logical type approach. And he even stated, I believe, that he believed that all you need to achieve general artificial intelligence, if you knew how to, was a Pentium computer, which is a computer 1,000 times slower than a modern computer. So, and of course, Marvin Minsky's student was Ray Kurzweil, the famous futurologist, the guy who's been able to predict so many things down to a year. And you should definitely check out Ray Kurzweil. He's an amazing guy. And Ray Kurzweil, for example, predicted that we're going to have singularity, i.e. where the machine becomes smarter than a human and then is able to kind of improve itself exponentially by the year 2029. I think he's even reduced that timeline since the advent of ChatGPT. So the program that you may be using every day, all day long, is ChatGPT. And that's been made by a company called OpenAI. And OpenAI is a Silicon Valley company. And they were the really first ones, I mean, to really make the whole thing, to make it available to the public. In fact, Google had a chat program before them, but for some reason they didn't release it. But they released it, I think, as of 3.5, ChatGPT 3.5. It became obvious that this is something unique and special. And of course, since then we've had ChatGPT 4, and we are really living in ChatGPT's world right now. Four worlds right now. And the reason why I say that is because all the other subsequent models, like the O5, for example, being the latest, I believe, they're really like, they use 4.0 underneath, if you like. So, and then they use something called chain of reasoning, where, you ask a question and then 4.0 has an answer, and then that feeds it back in and gets another answer, and then feeds it back in to refine it, and that kind of stuff. But the difference between 4.0 and 3.5, the one that worked first, is basically just the amount of data. So let's just recap where we are. So we have the symbolic camp, which is, as we stand, lost. And we have the artificial neural networks, or the transformers camp, which has won. And I mean, they've literally won, because last Christmas, Geoffrey Hinton won the Nobel Prize for Physics. But it was for AI basically. But and then Demis Hassabis, who is the CEO of DeepMind, which is Google's AI, won the Nobel Prize for Chemistry, using the artificial neural network approach. There's been really no symbolic kind of camp approach going on in practice recently. So we have the two camps. The artificial neural networks has won. We are living in Geoffrey Hinton's world. We are living in the artificial neural network, or the transformers world. And that's where we are right now. So now we have a bunch of companies doing these large language models. And they're, I would say, good for different things. So you've heard of OpenAI, which is basically a ChatGPT. We use it every day to like summarize text, to rewrite text, and that kind of stuff. But people are beginning to work out more and more ways of using it. So for example, inside of SuperThread, we are using something called function calling, which is basically the ability that ChatGPT has to give it programming interface, like the definition of all the endpoints, and then just ask it to perform a task, and it's just able to take what it has and use the right things to perform a task that doesn't exist inside of our software. Well, that's incredibly powerful. The problem is that it hallucinates. If you ask it two of the same questions, one after the other, it may give you a different answer each time. And of course, that's kind of a dangerous thing to have. So that's kind of the OpenAI. And now we have a company called Anthropic, which has a model called Claude 3.5, 3.7, and that's great for programming. So I do programming using a tool called Cursor AI. And basically, I have the option of choosing which model to use. and I basically stick with right now Claude 3.7 because it's really the best. And you know, the more you use it for programming, the better it gets, because it gets trained by the fact that people like me are actually using it. Because we kind of sometimes accept and reject code that it produces. And when I reject code, it knows that that's bad. When I accept code, it knows that that's good. So it's becoming better and better. So I think the gap between the ChatGPT and the Sonnet models is quite solid and here to stay, I think. And then you may have heard of a new companies like the Chinese DeepSeek. Okay, so they were able to recreate ChatGPT 4 by using ChatGPT 4, by using something called distillation. Okay, so distillation is like basically they made a program that chats to ChatGPT 4, and that's how it learns. Okay, so we have all these companies using artificial neural networks or transformers, and the way they were able to create these programs is by feeding them enormous amounts of data. Okay, so I'm going to say something that may be controversial, but it's all based on a paper called something like Attention is All You Need, which was written in 2016 or 17, something like that. And basically there has been no new movement in the field of AI. All that's been happening is that these companies have been feeding it more and more data. Okay, so the realization that that all you need to do is use this paper to create these programs, and that all you need to do is feed it more and more data is, I would give the credit to Ilya Sutskever, who used to work at DeepMind as an intern, and then he went to work for OpenAI. So I would give it to him, and also maybe Dario Amodei, the guy who's in charge of the Anthropic. So basically, so you have the field hasn't moved on at all. All that's been happening is feeding and this more data and training it. But it turns out that doing this is computationally expensive. All right, so to be able to train a model like ChatGPT 4, you need tens of millions of dollars. You need graphics cards. And graphics cards or GPUs, graphical processing units, they're like CPUs, but they have kind of more CPUs inside of them. So, and the company that you may have heard of that does the best ones is a company called NVIDIA. And you know, why NVIDIA? Why not AMD? Because they also make graphics cards. Is because it turns out that NVIDIA has this programming language that interfaces with their graphics cards that actually works really well, where AMD actually hasn't really quite gotten theirs right. So and then all these graphics cards are incredibly expensive. I mean, they're like thousands of dollars each, and then you need a lot. They need a lot of power, which means that you need data centers with a lot of power, and the data centers are quite hard to build. And the reason why data centers are hard to build isn't because you just put up a building, but you actually need water for cooling, and you need generators in case the power goes out. Plus you need a lot of power, of course. And for example, to get the generators, you're looking at waiting years now, you know, to get backup generators. So that's the kind of situation we find ourselves in. Now, once you train these models like ChatGPT 4, the inference is actually cheap. So that's not so expensive. So it's all trained, all the weights between the neurons are adjusted, and then you feed it in a word, and then for it to give you the next word is relatively easy because it's all been trained. So the CPU or the GPU power required for inference compared to training is like a fraction of the actual power needed. So that's basically what's going on with the inference. Now, how does something like ChatGPT work? Okay, how do these artificial neural networks work? Well, it's kind of vaguely based on the way our brain works. Okay, so our brain has neurons inside of it, and it has connections between neurons called synapses. Okay, and the synapses have varying strengths. Okay, and that's how artificial neural networks work. So in a program like ChatGPT 4, you have something called layers of neurons, and you have 100 of them, and you have the input and the output layer. And so you have one input layer and one output layer, and they're like, and then 98 in between. And each one of these layers has thousands of neurons. And then each one of these neurons from each one of these layers connects to every neuron in the next layer. So think of it like a plate, like this. So it's a plate and lots of neurons everywhere. And then there's another plate here, and each one of these neurons connects to the one in the above, and then so on and so forth. And now these connections are called weights, and that's how you achieve these. You know what the weights are by training, okay? By training on GPUs, and training, as I said, is expensive, and it's quite difficult to sort out the data needed for training, because you don't just want to give it anything. You want to give it something that you know is good, like a book, for example. So you need a lot of experts, like PhDs in their area, saying like, oh, you should read this. Let's feed it this data in. And a lot of the data out there is dirty. You know, like it's got lots of kind of programming things around it. So you just want the words. So, you know, like it's expensive cleaning that data up. But what the DeepSeek, the Chinese model, do, well, they took something that was already trained, like ChatGPT 4, and they just got their program to talk to ChatGPT 4. So they didn't have to worry about any of that kind of cleaning of the data. So they kind of bypassed the step of having to clean the data. Is that legal? Well, it's as legal as using somebody's copyrighted data. So the question whether that's legal is still to be answered. As well as, you know, like, is it legal for ChatGPT to use somebody's YouTube video without their permission to train its model? So I hope you guys understand, you know, like how the whole thing works, and I hope it makes sense. By all means, ask me in the comments if you feel that I missed something, and I look forward to hearing from you there. And I was also thinking about making like a series of such videos, going in depth, or like reporting on the AI news. I mean, tell me in the comments if you think it's a good idea. And anyway, so thank you very much, and I'll see you guys next time.